Hello everyone. Today I will discuss Codeforces problem, Codeforces round 890 div 2, okay, PermuTree, which is question number E1. So I have been given a tree with n vertices rooted at vertex 1, okay, and for some permutation a of length n, let fa be the, so we have been defined an function which returns the number of pairs of vertices in the tree u comma v such that this condition holds. A of u is less than LCA of u comma v, means the value at LCA of u comma v is greater than the value at node u, and which is less than the value at node v. Okay, and LCA is the lowest common ancestor. Okay, so find the maximum possible value of fa over all permutation a of length n. So uh, don't just be confused with this a. Basically what we have to do is that we have to assign each node each node a distinct value, okay, and uh, such that all the values are between 1 and n and all are distinct. That's what's the definition of permutation. So let's discuss with example, then you will be more clear about the question. Okay, so input pattern is you have been given first line will contains the number of nodes in the tree, and then second line will contain n minus 1 integers. So basically we have been given the parents of each of the node. Okay, so if I say that our tree has 5 nodes, then my uh, second node will be having parent 1, third node will be having parent 1, fourth node will be having parent 3, and fifth node will be having parent 3. Okay, so if you just see, the tree is like that. This 2 is the uh, 2's parent is 1, 3's parent is 1, fourth parent is 3, and fifth parent is 3. Okay, so what the a was talking about, we have to assign the values. So see here that we have assigned value 2 to the node 1, 1 to the node 2, 4 to the node 3, okay, and 5 to the node 4, and 3 to the node 5. And you should observe that 1 2 3 4 5 all are means forming a permutation of size n is equals to 5. So that's all about the question. So now we have to return the maximum value of f of a, and was what the f of a was. F of a is the number of pair of vertices u v such that the value at vertex u is less than value at LC of u comma v, and which is again less than the value at node b. Okay, so here you can see what the answer is 4 here. How 4? Let's see. If you consider node 2 and node 3, okay, what are the value at node 2 and node 3? And first of all, what is the LC of node 2 and 3? It is obviously 1. And you can see the value at node 2 is 1, the value at node 1 is 2, and value at node 3 is 4. So yeah, it is holding the condition. You can see in the explanation. And if you consider node 2 and 4, so what is the value at node 2? 1. Node if you consider 2 and 4, the LCA is again 1. So the value at LCA is 2, and the value at node 4 is 5. So again it is holding. So likewise we can obtain 2 comma 5 and 5 comma 4. That's why answer is 4. So let's move on to the solution part, then you will be more clear. Now what my approach is, I have already written it. So I will apply DFS and will consider each vertex as LC. Okay, so basically I will go to every node. I will suppose I start at the DFS at node 1. So if I am node 1, so I will consider this node as the LCA and will try to find, if I consider 1 as the LCA, so how many pair I can get which satisfies this condition. So if I consider 1 as LCA, so you can see these were the two pairs which was obtained considering node 1 as the LCA. Okay, node 1 as LCA. Sorry, it was basically these 3 pairs. You can see LCA is 1. So this I call as contribution to my answer. Okay, contribution is basically the number of pair of vertices which is satisfying the condition which of f of a I will get if I consider this node as the LCA. Okay, so let's again move to the solution. By contribution, I mean how many pairs I can obtain if this current node is LCA of two other nodes. Okay, I hope I am clear now. So now, how to count the number of pairs for a node? Suppose if I know how many number of vertices is having value greater than that of LCA node and how many having value lesser than that of LCA, then simply if I multiply both of them, I will get the number of pairs. So what I am saying is that suppose you can see if I consider one as the LCA, the number of nodes having value less than that of the LCA. What is the value at LCA? It is 2. So the number of node is having value lesser than that of the LCA is 1, which is node 2. Okay, and the having value greater than that of LCA is these 3. That's why if I multiply this, I will get 3, and you can see here obviously it is 3. So now the contribution would be the multiplication of these. Now, given the number of nodes in each subtree of a node B, which we can obtain by using, if you have done the problem like how many number of nodes are in a subtree of a node B, then you might got what I am saying. So now, given the number of nodes, so using TP, I can obtain the number of nodes in each subtrees of a node B. Okay. Then what I will do is that I will explore every subset sum as for assigning value lesser than that of LCA, then remaining, that is the subtree V minus S, will be assigned value greater than that of LCA. So what all I am talking about, but let's first uh, have take a look over how to obtain every subset sum of uh, subtrees for a node B. Okay, so I am talking about I will use bit set for obtaining all the possible subset sum. Let's see how. Suppose the node which we are considering is having m number of trees, and the number of the number of subtrees are m. Suppose this is the node I am considering, and it is having some number of subtrees which I have called m subtrees. Okay, m subtrees, and S1 is the number of nodes in the subtree 1, S2 is the number of nodes in the subtree 2, and Sm is the number of nodes in the subtree m. Okay, so suppose m is equals to 3. Okay, then S1, S2, S3 is 1, 2, 3. Just for sake of example. Now, before going to this, let's talk about the bit set in C++ STL. Bit set is like a number if you know about bit mask. Suppose if I say 5, how you represent this number in bit mask? Obviously, it is 101. So if you ever solve the problem with bit mask, you know that I can use this number to indicate a set. Okay. So what this one indicate that 0 element is present, one element is absent, one element is absent, and number 2 is present. I can use that because correspondingly I can say 0, 1, and then 2. So I can say the bit, if the bit is set, then that number is present in the set, or if it is unset, then obviously it is not present. So I will use this bit set in C++ is also used likewise bit mask. Okay, to indicate to represent a set. So suppose if I write the bit set 5000, uh, if you learn about the bit set, then you know that this will always be a constant number. Okay, so what does indicate that if I just write this syntax, what does indicate that this number will be having 5000 bits, 5000 bits. Okay, so now each bit will indicate a whole number from 0 to 499. Okay, that's what also usually number representing with bit mask also represent. So this bit set, now if I indicate if I just create a bit set of 5000, so which number I can represent using the bit set. Obviously from 0 to 4999. If ith bit is set in bit, means this bit, then ith number is present in our subset. I have told you, I have already explained using 5 also. If 101, just remember this. So let's obtain all the subset of the set A123. Okay. So now I want to obtain all the sums which are possible using 123. Okay. So if you just see, 1 is possible, 2 is possible, some 3 is possible, some 4 is possible if I take 1 and 3, and some 5 is also possible if I take 2 and 3, some 6 is possible if I take all of these. So I can say, and some 0 is also possible because if I didn't choose any element in my set. Okay. So just I will obtain all the sum using this, means I will iterate through the array and I will perform this operation. See, if you are not able to just understand this, then I will suggest you that first of all go through the bit set in C++. Now, since maximum sum can be 6, so I am creating a bit set with size 7. Okay, size 7, you can see if I just consider from 0 to 6, it will be of size 7. Now, if I will set 0 bit, now I will set 0 bit as 0. I will set as 0 sum is always possible. Why? If I as I have already explained, if I didn't choose any element in my set, so obviously the 0th sum is always possible. That's why initially I just set 0th bit as 1. Now let's iterate through the given set. I have said that I will perform this operation. Bit is equals to bit or logical or it is, and I will perform left shift operator AI. So now my after I have included 1, I can say the number has become this. Just carefully observe. If I just have taken 1, then which two sums are possible? Obviously 0 and 1. And you can see here that these two numbers are set here. That's the beauty of the bit set. Okay. So now if I include 1 in my set, then what would be the number become? It would become like this. So you can see here uh, some 0 is possible, 1 is possible, 2 is possible, 3 is possible. You can see, no? Now if I just included 3 also, then it will become this. And what is this representing? That all of these can be made using this number. So I will use I hope the bit set is clear. Okay, now let's move on to our solution. So now I will do what I will do is that I will explore every subset sum as and how I have already told you. Okay, every subset sum for assigning value lesser than that of LCA, then remaining, that is uh, I have explained, that what I am interested in if I am at a node is the number of nodes having value lesser than that of the LCA and the number of nodes having value greater than that of the LCA. Okay, so but I don't know. Suppose what I mean is that suppose I am having a node and this is having m number of subtrees, m number of subtrees, m number of subtrees. Then I don't know which subtree I will choose for the having uh, value greater than that of the LCA, and which subtrees I will choose for assigning value lesser than that of LCA. Means I don't know which will give me the maximum contribution, means maximum number of pairs for that node. Okay, that's why I will first of all store all the number using bit set. Means I will just obtain all the possible sum. Okay, and suppose if I am at some s using this, now you can see that I am talking about this. Now I have obtained this number, and how I have obtained this number I have already explained. Suppose if the number was 123, so what does 123 is indicating in my approach is that it is the sizes of the subtrees of a node which we are at present. Okay, so I can say here that all the number from 0 to 6, all the sum from 0 to 6 are possible by observing this number. Okay, so I am talking about that only. Suppose if the sum s is possible, if the sum is s is possible, now I will iterate from 0 to some number, let's say 5,000. Why? Because there can be sum of 5,000 also, because the maximum bound is 5,000 here. You can see the number of nodes is 5,000, so maximum sum can be 5,000. Maximum number of nodes in a subtree can be 5,000. And suppose if s is possible, if s sum s is possible, then what I will try is that, suppose I assign have these number of nodes having value lesser than x. X is the value I have assigned to the LCA. Okay, then obviously subtree of b, subtree of b, the b is the node which I am at present. Okay, subtree of b minus s, subtree of b minus s will be the remaining nodes, so I will assign them value greater than x. So obviously I will I can obtain the contribution as multiplying by both of them. I have already explained. Now I will take maximum for all the subset sum which are possible. Why I am doing so? Why I am exploring all the subsets? Because I don't know taking which subtrees for assigning value greater than and to which assigning lesser than that of LCA will give me more number of pairs. Okay, so I hope I am clear now. Let's move on to the solution part. Let's move on to the solution part. So I have already taken the test cases. I will just I will take a parent for storing array for storing parent, and I will take a adjacency list for creating the tree. Okay, now I am following one page indexing. It's all up to you what you follow. PV is the pushback function. I have created macro for that. Now I will create a variable. Okay, I will also create a vector sub which will represent, which will store the number of nodes in the subtree of a node B. Okay, now I will call TFS from 0 from the root, from the node from the root which is 1, and pass the parent as 0, then G, and then sub and answer, and finally I will just print answer. Now all I am left with is to write the DFS code. Void DFS, void DFS int v, then int p, and then vector int g, then vector int ampersand sub, and then answer. Now I will take a bit set of maximum 5,001, because although it can go for to 5,000 also, that's why for the safeness I am taking it and naming this as, you can also name it as bit or TP, whatever. Let's name it TP itself. Now for auto ampersand 2 and G, I am going to every child, if 2 is equals to P, then continue. Otherwise I will make a recursion call to the child to bring me the number of subtrees, it has. Okay, and just observe why I have not written like this: sub of b is equals to 1. If you have done the subtree sum problem, obviously you would have done so, but why I am not doing so? Because I am not interested in, I will not include the node I am at present. I will exclude it because uh, I want the other two nodes, because this node has already been included in that relation. Okay, means the a of u is less than lc of ub. Okay, the lc of ub is already being counted. Now, when I will return, then I will just add the number of subtrees in the child. Basically, 2 is the child. And now also, what I will do, I have already explained. dp of is equals to dp sub of 2. I am just observe that I am just taking the sizes of the child. Okay, number of nodes in the child, subtrees of child. Now, int contribution. Int contribution is equals to 0 for int I is equals to 1, I less than equals to 5000, I plus plus. if if dp of I means this sum is possible, if this sum is possible using the sizes of the subtrees of children's of this node v. Okay, I mean to say, then I will take the maximum of the number of pairs I can get using this sum as, for assigning the having value lesser than that of the LCA. Finally, I will just add up this contribution to my answer. And finally, after when I just return from this node, then I will increment its size. Means now I will include this in the subtree of its parent. Means of this node. Now I will count. Okay, so let's run. Let's see what the problem is. Oh, sorry, I forgot to dp dot set. What I have told you, that zero sum is always possible. That's why I will have to set this priorly. Now all has been passed. So thanks for watching.